section 4.3, we solved one-step equations with addition and subtraction. Today we're going to look at how to do it with multiplication and division. Now these first two statements are identical to what we had in section 4.3. Just a reminder that to solve an equation, we have to get the positive version of the variable by itself with no coefficient. So we have to get x or y or z. Let me write that better, I'm sorry. Getting in a hurry. Coefficient. There we go. That's better. C-O-E-F-F-I-C-I-E-N-T. So we have to get x by itself. We can't have negative x. We can't have 4x. We can't have negative 3x. It's got to be just x. To get the variable by itself, just like before, we'll have to do the opposite, or the inverse is the math word for it, of the operation that is happening to the variable. So if there's a number being multiplied by the variable, we have to do the opposite and divide, because the opposite or inverse of multiplication is division. If there's something being divided by the variable, or if the variable is being divided by something, the opposite of that is multiplication. So here, x is being multiplied by negative 9. So to get x by itself, we need the opposite of that and divide by negative 9. So a positive divided by a negative is negative, and 72 divided by 9 is 8. And we can check that. Negative 9 times negative 8 is positive 72. Okay, 2 is the same format. We're starting with multiplying. 5 is being multiplied by y. So we do the opposite and we divide both sides by y. So the 5 cancels out. Now, yesterday with adding and subtracting, they canceled out because they added up to 0. Like negative 3 plus 3 equals 0. This has gone away. But here, it doesn't cancel out to 0. It cancels out to 1. 5 divided by 5 is 1, so we just have a 1y, which is what we're going for. 60 divided by 5 is 12. Okay, now on 3 we're switching gears. X is being divided by a number. So we're starting with division, so our job will be to do the opposite and multiply. So x is being divided by negative 13, so we need to do the opposite and multiply both sides by negative 13. I won't write this every time, but this is really negative 13 over 1, because any whole number can be put over 1. So then, just like we've done with reducing other things, we have one on the top, one on the bottom, they cancel out. Dividing something by itself gives you 1, so this is really just 1x. We don't bother writing the 1. A negative times a negative is a positive. 5 times 13 is 65. Okay, same process on number 4. A is being divided by 11. So we do the opposite of division, we do multiplication. We multiply both sides by 11. So the 11s cancel out right here, leaving us just 1a. And 13 times 11 is 143. Make sure I'm thinking that right. 130 plus 30, yeah, 143. Okay, now on number 5, x is being multiplied by negative 2/3. So you could say I need to divide both sides by negative 2/3. Mathematically, that's completely correct to say that. But dividing by fractions is tricky. In fact, what we say in math is to divide by a fraction, you have to multiply by its reciprocal, meaning dividing by negative 2/3 is the same thing as multiplying both sides by negative 3/2. So these 3's cancel, these 2's cancel, leaving us just 1x. And we're ignoring this because we're multiplying now. So if we treat this as 12 over 1, 12 times 3, sorry, it should be a negative, my fault. 12 times negative 3 is negative 36. 1 times 2 is 2. So right now we get x equals negative 36 divided by 2, which is negative 18. So that's one way to practice that, but I'm going to show you another way you can approach it. Now, I did it this way first because this is titled one-step equations. And you certainly can do ones like this where there's a whole fraction in front of the variable. Like up here, the variable was in the fraction, it was part of the fraction. Same here. But here we had a whole fraction on its own in front of the variable. So I showed you this method first because that does make it one step, like the lesson says. But in my opinion, it's a little easier if you change it to a two-step question. So I just rewrote the question right here. I know I don't want a denominator, so the way I get rid of the denominator is multiply both sides by it. That leaves me with negative 2x equals 36. Well, I got to get rid of the negative 2 as well. Right now it's negative 2 times x, so I divide both sides by negative 2, and I get x equals negative 18. So you can get the same answer both ways. You can choose which way you want to do it. We'll hit another one on the back of this section, and I'll do it both ways, but I'll just want you to know it can be done either way. So back to a simpler one in number 6. This is 8 times b. They're multiplying, so we want to do the opposite and divide. A negative divided by a positive is negative. 64 divided by 8 is 8. And just a reminder, the variable is allowed to be on either side of the equal sign. Does not matter if it's on the right or the left. 7, we're dividing. D divided by negative 8. So we do the opposite of division, and we multiply both sides by negative 8. So over here it cancels out. Negative times a negative is positive. 6 times 8 is 48. Okay, it's being divided here as well. X is being divided by 3. We have to do the opposite of dividing, so we multiply both sides by 3. This cancels out, leaving just the x. 3 times negative 9 is negative 27. Okay, sometimes you'll have decimals. And if you have decimal, I mean, you can use it even without a decimal, but you are allowed to use a calculator if you need to. But we would divide both sides, because this is negative 0.3 times n, so we divide both sides by negative 0.3. A negative divided by a negative is positive. 3.9 divided by 0.3 is 13. Now, if you want to know how you can do that in your head, you're allowed to shift this decimal over one spot as long as you do it in the top and the bottom. Meaning this is really 39 divided by 3, and that's 13. Or it's the same as 39 divided by 3, I should say. Okay, here in number 10, we have another one like we did on the previous page, where we have a whole fraction in front of the variable. So to do it the one-step way, we divide by 2/5, and dividing by a fraction is the same as multiplying by its reciprocal. So we multiply both sides by 5/2, because that's good because it cancels out the 5's and the 2's, leaving just the m. On this side we have 5 over 2 times negative 4 over 1. 5 times negative 4 is negative 20. 2 times 1 is 2. So we get negative 10 is equal to m. Or if we want to do it in 2 steps, we could say, okay, I don't want that 5 because it's a denominator. That makes things hard. So I multiply both sides by 5. 5 times negative 4 is negative 20. Then this is 2 times n, so we do the opposite, we divide. We get negative 10 equals m. So you get the same correct answer either way. Okay, on 11. One reminder is when you have a fraction, you can write the negative anywhere. In other words, negative 1 over 3, that's the same thing as 1 over negative 3. Or the same thing as having the negative out front of the fraction like this. So all three of these mean the same thing. The negative can be in different spots, but it still means the same thing in a fraction. So I think it's easier in this case to move the 3 down, or the negative down with the 3. Because then we can think, okay, if I multiply by the reciprocal of this, because, let me back up. This is negative 1/3 times y. So I would need to divide both sides by negative 1/3. But dividing by a fraction is the same thing as multiplying by its reciprocal, so that's a 1. So the negative 3's cancel, the 1's cancel, leaving just a y. A positive times the negative is negative. 17 times 3 is 51. Okay, last one, we're multiplying by the variable 7 times x. So we do the opposite, we divide. A negative divided by a positive is negative, and 42 divided by 7 is 6.